So what's a metal? Well, metals are elements, nature's building blocks. We get the word metal from Greek, metallion, meaning mine or quarry. The cloud or the soup of negative electrons is attracted to the positively charged nuclei, creating the force, the metallic bond that holds metals together. And it is the metallic bond that gives metals their properties. They are extremely strong metallic bonds. The metallic bond is one of the strongest bonds that nature forms. Metals can expand with heat. They can grow, contract. They grow and contract with cold. They shrink. Metals can turn into a liquid. We can melt them. Not all elements melt. Metals are fusible. We are able to fuse them together. We are able to melt them together, effectively weld them together. Metals are hard. Metals have high strength. Metals behave elastically like an elastic band and plastically like plasticine. They are malleable. We can move them around like plasticine. We can shape them, and ductile, so we can shape and stretch metals. Metals are shiny. They have high electrical conductivity. They have high thermal conductivity. All of these unique properties as a result of the metallic bond, this cloud of negative electrons that is shared amongst all the atoms and holds them together, the metallic bond. It is that that gives metals their unique properties. Now, metals dominate the periodic table, and the periodic table is the list of all the metals that exist in nature. And each element, each metal is given an atomic number, which is the number of its protons. Remember, atoms never lose a proton. We're interested in aluminium, and the aluminium atomic number is 13. Just to reiterate, the higher the number of the protons, the higher the atomic number, and the higher the atomic number. And the higher the weight. The larger the atomic number, the larger the weight. Remember that protons and electrons have a weight. So the larger the atomic number, the heavier a metal is. So aluminium has an atomic number 13. It is a light metal. Let's look a little bit at electrical conduction. Remember, electricity is the flow of electrons. That metals are held together by the metallic cloud, which is a cloud of fast-moving electrons. So if we pass an electric current into a metal, we effectively inject electrons which flow through the metal, through the electron cloud, and the same number of electrons is ejected. Hence, we have electric flow. Thus, metals are good electric conductors. In a similar manner, thermal conduction, metals are held together by the metallic cloud, which is a cloud of fast-moving electrons. Now, heat is energy, and heat and energy excites, increases the motion, the vibration of the electron clouds. So if we put energy into an atom, the cloud of electrons gets more and more excited. Its vibration rate increases. And effectively, the vibration is transmitted throughout the metal and then conducted as heat, hence thermal conduction. So if we put heat energy into an atom, its electrons get excited, they get vibrate more and more, and they transmit that vibration through and then emit it as heat, thermal conduction at the other end. Remember, it's the electron cloud that keeps things together, the metallic bond. Now, metals are held together by the metallic bond. And when metals are heated, the energy of heat that we put into the atoms increases the vibration of the electrons. And this forces or causes the electron orbits to increase the spacing from the nuclei, increasing the orbit diameter. Effectively, if we heat up an atom, the electrons get more and more excited. Because they spin and vibrate more and more, the orbits grow further away from the nucleus and increase in size. The larger the electron orbit, and as they grow, the electron orbit diameter increases in size, effectively increasing the size of the individual atoms, pushing them apart. So when we heat up a metal, the energy that we put into the metal causes the orbiting electrons to get more and more excited, to widen their orbits, their shell orbits space, which effectively increases the size of the atoms, and increasing the size of the atom effectively pushes the atoms apart, so metals expand. So increasing the temperature increases the separation of the atoms. Now, because we increase the separation of the atoms, we separate the atoms further, so the strength of the metallic bond decreases with temperature. So if we heat up atoms, the electrons vibrate faster. Effectively, they grow the size of the atoms, increasing the spacing of the atom to atom. Because we increase the spacing of atom to atom, we decrease the strength of the metallic bond. So increasing the temperature reduces the strength of the metallic bond. Conversely, if we decrease the temperature, the diameter of the orbits reduce, the space in the metals contract, and they get stronger with colder temperature. The larger electron orbit diameters force a greater separation between the atoms. Increasing the temperature increases the separation, so decreases the attraction between the negative electrons and the positive protons, decreasing the strength of the metallic bond. So it is very, very important that you realize that increasing the temperature reduces the strength of the metallic bond, which means that the force that we require to change the shape of metals is dramatically reduced with increasing temperature. Conversely, decreasing the temperature reduces the orbit, so the spacing of the metals is shrunk and their strength increases with temperature. And the ability to heat metals up to reduce the strength of the metallic bond is the fundamental process that we use for hot working, for extrusion, and in some cases, welding. Let's talk a little bit about ductility. Now, the cloud or soup of negative electrons is attracted to the positively charged particles, the nuclei, creating the metallic bond that holds the metals together. Now, no two metal atoms are directly held together by the metallic bond. So as long as we do not break the metallic bond, that is the force holding two atoms together, we can move the atoms about, so we can reshape metals. And the ability to reshape metals is called ductility. And ductility is the metal's ability to be plastically drawn out, to be permanently stretched without breaking the metallic bond. It's a measure of the metal's ability to withstand plastic deformation, so we can work metals like plasticine under a load without rupture or failure. The greater the strain or elongation or stretch that we can impart to a metal, the more ductile a metal is. And fundamentally, ductility is the property essential to the ability of a metal to be cold worked or hot worked or reshaped. I trust you've learnt about metals and atoms, and that you understand the importance of the metallic bond, that it is the metallic bond that gives metals their unique properties. So I hope you've learnt something from the module. Please see further reading, particularly on atoms and metals. Thank you very much, and I hope you've enjoyed this course. Thank you.